Q naught minus Q naught, C2, this is L. So this is the charge Q naught initially. So I'm going to close the switch S2. So for what interval of time? For a certain time T2, I'll close it, then I'll open it here. So by the time, so this is still open, and this is being closed. So charge Q1 minus Q1, C1, and this is C2. So there'll be charge and there'll be current. Let me call that as I1. This is switch S1. For what time it is being closed? For a time T2. This is at T equals 0, it is closed. Then for till T equal to T1, what will happen? A current will be flowing at this moment. At time T1 open, I'm going to open the switch S2. I'll open the switch S2. So then, so first we'll do one thing. We'll write equation. One equation will end up Q naught 2C1, Q naught square by 2C1 should be equal to Q1 square by 2C1 L I1 square by 2. Fine. Okay, what is the question asked? That T1 by T2. Next, what happened? Immediately at time T1, for time T1, the switch S2 is being closed. Now I'm going to open it. So when you open it, there's a condition. C2, this what the condition is like this. So this was having a current I1 and this was having a charge Q1. Now immediately open, this is being closed. Immediately this is being closed. It's there immediately. So no, actually spark will come, is asking neglect spark here. So then what is the condition will arise? So it will be like this here. And afterwards, this Q1 charge will remain as it is, leave it. So here, what was the current? I1 was flowing and there was no charge. So now, for what interval of time? For T2 interval of time, this is being closed. So here it will have some charge, you say Q dash minus Q dash. Here current, I dash will flow. Finally, when the charge has become Q2 minus Q2, let me call that I2. I think this is the sequence. If you can understand, it's all about writing equation. And now, what all that energy in the inductor now here? The energy in the inductor here. This is what the energy in the inductor and capacitor, conservation of mechanical energy. So you see this. So therefore, what is the equation I can write? L I1 square by 2 is equal to L I2 square by 2 plus Q2 square by 2C2. You should not bring this energy into the picture here. What all the energy in the coil, that will be shared by now the coil and the capacitor. I think no need of drawing so many diagrams in exam. Just to make you understand, I just brought the sequence here. Okay, fine. After this, what was this is a T equals 0, no? The moment, the sequence T equals 0, this is what time? T equal to T2. So if I start counting time for the current, so initially what was the current across the coil? The current across the coil was non-zero. So shall we write equation for the current through the coil? The equation for this I2 is equal to IL is equal to I1 cos omega 2 TU, right? What is omega 2? Omega 2 should be 1 by root of LC2. Because the moment you open the switch S2, close S1, that is you should start counting the time. So can I write this? And when the current has become, like when current to the coil, when the charge across capacitor has become Q2. So we know Q2 is Q2. Q2 is C2 into 300. Am I right? So we know Q2. Then from substituting this, we'll get relation between I1 and I2. Okay. Look at here. We'll get I1 and I2. Then here, in this equation, when the current across the coil has become high to Then the switch, what will happen? The switch S1 was open, no? So this will become T2. So two equations, two unknown. I2 I'll get in terms of I1, that I'll substitute. Okay, clear this. So we'll get this T2. Then if you know this T2 and you can bring the I2, then you can calculate I1. From here, that I1 you can substitute. So like that, you can calculate that T1 also. What should be the T1? For T1, you should write equation like this. Charge across capacitor is equal to Q naught cos omega 1t. When the charge has become Q1, when the charge has become Q1, Q naught cos omega T1. I think a little bit lengthier. So if you see this I2 in terms of I1, you bring it, substitute here. I1 get eliminated, then we'll get T2. After getting D2, you'll get I2. Substitute here. We know Q2 will get I1. That I1 you have to substitute here. You'll get Q1. That Q1 you have to substitute here. You'll get T1. Then T1 by T2. Okay, I'll go for next one. Minimum possible, for the minimum possible values of time in minimum